9 distillation columns, 4 catalytic cracking towers, 12 storage tanks holding a combined capacity of 340,000 cubic meters of crude oil and refined product. One of the largest refining complexes in southern Russia, processing over 140,000 barrels per day. Its output supplied aviation kerosene to 3 Russian air bases and diesel fuel to frontline logistics depots across the southern military district. One night, 14 Ukrainian drones flew over 800 kilometers to reach it. By morning, it was burning. The refinery complex sprawled across nearly 2 square kilometers of industrial flatland east of Volgograd, near the western bank of the Volga River. It had been operating at near maximum capacity since the start of the full-scale invasion, running double shifts to meet the military's surging fuel demands. Russian commanders considered it a safe asset, deep inside Russian territory, far beyond the range of conventional Ukrainian artillery, protected by an S-300 battery 30 kilometers to the north, and a pair of Pantsir systems guarding the perimeter. The nearest Ukrainian-controlled territory was over 700 kilometers away. No weapon in Ukraine's known arsenal could reach it, or so they believed. Ukrainian drone engineers had been quietly extending the range of their indigenous long-range strike platforms. The latest variant, a delta-wing design with a pusher propeller and a fuel-efficient 2-stroke engine, could fly over 1,200 kilometers at low altitude on a single tank. It carried a 30-kilogram high-explosive fragmentation warhead with an incendiary sleeve designed to maximize fire damage against fuel and petrochemical targets. The airframe cost approximately $50,000. The engine was derived from a commercial paramotoring unit. The guidance system combined civilian GPS with an inertial backup that could maintain course even through GPS jam zones. Ukraine had built a weapon that could reach deep inside Russia for the cost of a used sedan. 14 drones launched from 3 dispersed sites in central Ukraine over a 2-hour window beginning at dusk. They flew individually, not in formation, each following a unique routing that avoided known air defense positions. The routes had been planned using a combination of electronic intelligence, satellite imagery, and data from previous strike missions that had mapped the coverage zones of Russian radar and SAM systems along the flight path. Some drones flew northwest through Belarus airspace margins before turning south. Others took a direct southeastern course, hugging terrain features. 2 flew a southern arc over the Sea of Azov before turning east. What happens when 14 drones approach a target from 14 different directions? Russian air defense doctrine assumes threats come from predictable axes. The answer to that assumption was about to arrive at Mach 0.5 from every compass point simultaneously. The first Russian radar contact came at approximately 1:45 in the morning, when an S-300 battery northeast of the refinery detected 2 drones approaching from the northwest at low altitude. The battery commander alerted the Regional Air Defense Coordination Center and engaged. Both drones were shot down. Their northwestern route had taken them directly through the S-300's primary search sector. Confirmed kills. Reports filed. The defense network registered the attack as intercepted. But those 2 drones were the Sacrificial probes. Their flight path had been deliberately routed through the densest radar coverage to confirm the S-300's engagement patterns. The telemetry from their loss, the exact moment they were detected, the range at which missiles were fired, the intercept altitude, was not available to the remaining drones in real time. But it didn't need to be. The mission planners had already predicted the S-300's behavior based on previous engagements and had routed the other 12 drones around its coverage arc. At 2:11, the main wave began arriving. 3 drones approached from the southeast, flying at 12 meters altitude over agricultural flatland. 2 came from the south, following a river valley that created a radar shadow. 4 approached from the east, crossing the Volga at its widest point where ground clutter from the river surface degraded radar performance. The remaining 3 came from the southwest. The Pantsir systems guarding the refinery detected the first incoming drone at a range of 6 kilometers. The operator engaged. The first missile missed. The drone was too low, and the Pantsir's tracking radar struggled with ground clutter at that engagement angle. The second missile connected, destroying the drone 3 kilometers from the perimeter. But the operator had spent 45 seconds engaging a single target. 11 more were inbound. Stay with me. 11 drones, 2 Pantsir systems, 6 kilometers of open ground. The math does not work in Russia's favor. The Pantsir systems could engage targets sequentially, one at a time. Each engagement cycle required approximately 30 to 40 seconds. Detection, tracking, lock, fire, assess. Against a single drone or a small group approaching from one direction, this was adequate. Against 11 drones approaching from 4 directions simultaneously, it was impossible. The systems could not rotate fast enough to switch between targets in different sectors. While one Pantsir was engaging a drone to the southeast, 3 more were approaching from the east uncontested. The first drone struck the refinery at 2:14. It hit the number 3 catalytic cracking tower at its base, where feed pipes connected to the main processing unit. The warhead's incendiary sleeve ignited residual hydrocarbons in the pipe network. A column of flame shot 60 meters into the air. The temperature at the impact point exceeded 1,000 degrees within seconds. The second drone hit 40 seconds later, striking a cluster of storage tanks on the southern perimeter. The tank it hit contained naphtha, a highly volatile refined petroleum fraction. The explosion was immediate and violent. The tank ruptured, spraying burning naphtha across 3 adjacent tanks. A chain fire began spreading through the tank farm. Over the next 6 minutes, 9 more drones struck the complex. They hit distillation columns, pipe junctions, pump stations, the control building, and 2 more storage tanks. Each impact added another fire. The incendiary warheads were devastatingly effective against petrochemical infrastructure. Every pipe, every tank, every processing vessel contained flammable material. Each drone that got through created a new ignition point that the refinery's firefighting systems could not contain. How long did it take for the refinery to become an uncontrollable inferno? A, 6 minutes. B, 14 minutes. C, under 3 minutes from the first impact? The answer is coming. By 2:20, the refinery was burning across its entire footprint. Satellite thermal imagery showed surface temperatures exceeding 800 degrees Celsius at multiple points. The smoke plume was visible on weather radar from 300 kilometers away. A column of black smoke rose to an estimated altitude of 4,000 meters, visible at daybreak from the outskirts of Volgograd itself. Local emergency services were overwhelmed. The refinery's internal fire brigade had been designed to handle single-point industrial accidents, not simultaneous fires across a dozen locations. Russian firefighting crews from 3 surrounding districts were mobilized. They arrived to find a facility that was beyond saving. The catalytic cracking units were gutted. 3 distillation columns had collapsed. 7 storage tanks were burning or had already exploded. The control building was destroyed, eliminating the ability to remotely shut down processing systems and isolate fuel flows. Burning crude oil was flowing across the compound through drainage channels designed to carry rainwater. The fire burned for 4 days. The answer, C. Under 3 minutes from the first impact, the fire had spread to the point where containment was impossible. The combination of incendiary warheads and the inherently flammable nature of refinery infrastructure meant that each successful drone strike exponentially accelerated the destruction. By the time the 4th drone hit, the facility was already experiencing cascading thermal events that no firefighting capability on Earth could have stopped. The economic impact was staggering. The refinery's processing capacity, 140,000 barrels per day, was completely eliminated. Repairs were estimated to take between 8 and 14 months, assuming all necessary equipment could be sourced under sanctions. The cost of rebuilding was assessed at over $1.2 billion. But the immediate military impact was more significant. 3 Russian air bases lost their primary aviation fuel supply. Frontline logistics depots in the southern military district reported diesel shortages within a week. Russian commanders were forced to redirect fuel from reserves as far away as the Urals, stretching an already strained logistics network to its breaking point. The tactical lesson is about economics as much as warfare. 14 drones at $50,000 each, total strike cost of $700,000, destroyed a refinery worth over $1 billion and eliminated 140,000 barrels per day of processing capacity. The return on investment exceeds 1,000 to 1. More importantly, every drone that Russia shoots down still costs them more than the drone itself, because the interceptor missiles used by Pantsir and S-300 systems cost between $500,000 and $2 million each. Ukraine can build drones faster than Russia can build interceptors. The math is relentless, and it favors Ukraine. Was the 14-drone saturation approach optimal, or would a smaller strike with larger warheads have been more effective? Could Russia have protected the refinery by adding more air defense layers? What would you have done differently? The refinery east of Volgograd is silent now. The distillation columns that once processed crude oil around the clock are twisted steel skeletons. The storage tanks are blackened shells. The smoke has cleared, but the economic damage compounds every day the facility sits idle. And somewhere in central Ukraine, drone engineers are testing the next airframe, extending the range another 100 kilometers, refining the navigation algorithms, and loading the next batch of incendiary warheads. Because oil that cannot be refined cannot fuel tanks, and wars run on fuel.